Okay guys, video 2, solving simultaneous equations by elimination. Okay, let's go through the steps again. So, as we did before, we are going to, I'm just going to draw 2 columns because I don't have much room here to squash everything in. You can spread it out on yours. I'm just going to write the equations below each other because for me that just helps me see the relationships between them a little bit more easily. So 4 equals y equals 32. Okay, that I'm going to call equation A, that I'm going to call equation B. Okay, so step 1 says to multiply each equation by a suitable number so that the 2 equations have the same leading coefficients, and it really should say of one of the variables. So what it's saying is you want to get either y or x in both equations having the same coefficient. Because if you did, so say if this was 2 and this was 2, when you subtracted these equations from each other, you would actually end up eliminating one of the variables, because you would have 2y take 2y, and that would be 0 for that part of it, and then you can just find x. So to do that, we're going to multiply equation b by 2. So that's going to be our first step, is to multiply equation b by 2. Again, write down what your steps are. So multiply b by 2. That's step 1. Okay? If we do that, and if we multiply b by 2, we get 8x plus 2y equals 64. Why did I do that? Well, I did 2 times 4x plus y. And 4x plus y equals 32. We would never write it like this, but just to help us see. So 2 plus 2y equals 64. That's where that came from. Okay, so now we've got that. 8x 2y equals 64. Alright, now we're going to do step 2. The eraser. 8x plus 2y equals 64. Now we're going to do step 2, which is subtract the second equation from the first. Okay, what that means is subtract the equation that you've just done, that you've just made, i.e. this one, from the other equation that you haven't really done anything with. So I'm going to call this equation C. Okay, and I'm going to do subtract the second equation, or this equation, from the first. So I'm going to write that out. So subtract C from A. You could do A from C. Doesn't really matter. So C from A. So if I do that, I'm going to have 3x. Just write it like a subtraction problem. Change the colours. 3x plus 2y equals 25 minus 8x plus 2y equals 64. Okay. When you do that, as you see, you're actually getting, so then you subtract 3x take 8x, negative 5x. 2x, 2y, take 2y, ooh, 0, equals 25 take 64. Now, 25 take 64 is equal to 25 take 60 is negative 35, negative 35 take 4 is negative 39. Testing my algebra skills there. Though I do have an answer, so I can cheat. X, therefore, is going to equal 39 divided by 5, because it's really equal to negative 39 divided by negative 5, and you get rid of the negatives. Okay, so we've got X now. Brilliant. Okay, so that was step 2 right there. Okay, and step 3, we've solved this new equation for X and Y. So all we've got left is step 4. Substitute X or Y into one of the original equations to find the other variable. Okay, so it doesn't matter which one, but I reckon B looks easier again because it's only got a coefficient of 1. So sub x equals 39 over 5 into B. If you do that, we're going to get 4, so 39 on 5 plus y equals 32. And so 4 times 39, well 4 times 40 is 160, so you're taking 4 away. So that's going to be 156 on 5, 156 on 5 plus y equals 32. So y is going to be 32, take 156 on 5, which is going to leave you with, apparently, something, well, let's actually work it out. So 32 take 31 and a fifth. So 32 take 31 and a fifth, which is going to equal 4/5. And so the point where these two lines intersect is 39 on 5, 4 on 5. Okay? 39 on 5, 4 on 5. The code for this one is B. ZB. If you've listened to both videos, you should